I are here to go over a AP Calculus problem. How you doing today, Peter?
I'm doing fine.
Peter's doing fine. At least if you have anything extra words, we're going to slide on that one right there. So we're going to look at this problem from the 2011 AP exam. And I'm going to read the first piece of information. It says, let R be the region in the first quadrant, bounded by the two graphs, x equals 8 to the third, and g of x equals sine of pi over x. Hey, Peter, if you were to guess which one is the upper curve and which one's the lower curve, what would you think?
I would have to guess sine.
Sine, you would guess sine is what?
The upper curve.
He's right about that, because sine, we know, starts down low and goes up. So this graph is the sine of pi x. And that makes the other graph 8x to the third. I don't know if we need to do that yet, Peter. Let's see what the problem asks us to find. It says, write an equation for a line tangent to the graph. So Peter, if we're finding a line tangent to the graph, what equation are we going to be using?
We need the Joe Pesci.
Line! Line, please, sir! Line!
Get your derivative. Your cross-country team.
And,
Forget you.
correct. So, Peter's got the correct equation. So we're going to need a couple things. We're going to need a function we're going to work with, an f of x. We need the derivative of that function. And we're going to need to know what c value we're working at. So if we look back at the problem, we'll see f of x is 8x to the third. And the equation we're using, sorry, the point we're using is x equals 1/2. Don't be fooled by that x. They're telling you where to start. There we see the problem. So c is equal to 1/2. Peter, what was f of x?
8x to the third.
8x to the third. So Peter knows the derivative is
24x squared.
24x squared. And now we're going to substitute 1/2 into here, 1/2 into there, and 1/2 into there. What's f at 1/2 is 8 times
1 over 8.
1 over 8. That equals 1. And this is equal to 24 times 1/4. And that equals 6. So Peter, I'm going to write my equation. L equals 1x minus 1/2 plus 6. Peter, did I put all that stuff in the right locations?
I don't think so.
Peter is correct. I
The
always double check
should be first
to make sure I'm putting things in the right spot. F prime of c goes first.
and plus 1.
1 goes afterwards. That's our equation for a local linear line. Let's see what the next question asks us to do. So, hey, Peter, that was a short one. Why don't you read that one to us?
Alright. Find the area of R.
Find the area of R. So Peter's going to find the area of R. And Peter knows that area is always equal to sublow, upper minus lower, upper minus lower. So Peter, if we look back over here, who's our upper curve? Oh, wrong question, Peter. Come on. Don't click the wrong stuff there. Peter already said our upper was sine pi x. Our lower was 8x to the third. Where are we starting, Peter? We're starting at,
0.
and we're going to
1/2.
from 0 to 1/2. All right, so we come back to our problem. We're going to integrate from 0 to 1/2. Upper, which was 8x to the third, minus lower. Oop, I almost wrote the word lower down there, Peter. What was it? Sine
I think it was sine pi x.
pi x dx. And Peter, I can think of these as one problem altogether. When I find the integrals, I would think of each part as a separate piece right now. So what's the integral of 8x to the third?
2x to the fourth.
Right, Peter shortcut it for us. It's really 8 over 4. I'll just write it really quick. 8 over 4 x to the fourth, but 8 over 4 is 2. Minus, now I've got to integrate this thing here, but I can't take the integral until I have the derivative of the inside sitting there.
Pi.
Peter says pi is derivative of the inside, so I'm going to put a pi there. So what's to go on the outside of the problem, Peter?
1 over pi.
1 over pi. And now we're going to take the derivative, or the integral of sine of pi over x, integral of sine of something.
Negative cosine.
Peter says negative cosine. I think he's right. I'm going to write it down here. Derivative cosine. Yeah, it is a negative cosine, Peter. So if I put a negative sign there, that's the same as turning this one to a plus sign from 0 to 1/2. Now the reason that 1 over pi goes there, Peter, is I'm thinking of this as two separate problems. Two separate pieces I'm integrating along the way. So I have to go and manipulate that. That's where I'm going to go. And now, Peter, I'm going to fill in the numbers, but I'm not going to solve anything out. I just have to evaluate cosines and sines. So let's fill it on in. 2 1/2 to the 4th plus 1 over pi cosine 1/2 minus 2 0 to the 4th plus 1 over pi cosine 0. Peter, because it's a non-calculator problem, that's all I have to do. I don't have to find what the answers are. I just have to put the numbers in.
That's awesome.
Yep, if you feel like doing it, hey, do what you gotta do. So last part of the problem. Let's see what they asked me to do here. Write, but do not evaluate, an integral expression for the volume of a solid when r is rotated around the line y equals 1. Okay, Peter, they asked me to come up with a number for this?
They are not.
They are not. I'm going to draw the line y equals 1 on there. The line y equals 1 is right here. And whenever we're doing volumes of rotations, who's coming into play?
Yeah.
I'm going to write it down. Pi, integral, parentheses, y minus a squared minus y minus a squared dx. They just want me to fill that information in. And it's still a rotation problem, so it's always upper minus lower. Okay? We're going to solve that problem whether we have it or not. But now let's look at our graph. And let's think about rotating these two curves around that line. Peter, if we rotate these two curves, who's going to be on the outside of the graph?
The side.
I'm going to highlight what would be the outside of the graph. Because it's going to rotate and it's going to go up.
Oh, alright.
And that's the trick on these. If the line is above, you have to think of bringing your whole shape and bringing it up on the outside of the graph. Because it's going to come up and be up here. So it's actually the upper is 8x to the third.
So it's not always just the upper curve.
It is the upper curve based on the shape that you rotate. It's the upper curve. But we're gonna take care of it. We wouldn't even have to worry about it. So it's gonna be pi, the integral. It was 8x to the third. And our axis was 1.
Yep.
Minus 1 squared minus sine pi x minus 1 squared dx. And this would be correct written out thing, but Peter, like I said before, if we do it backwards, what do we get in terms of the answer? We get the same number, but the wrong sign. So to make something positive, all I do is, before I actually evaluate it,
Absolute value.
I can put the absolute value in there. This way, if I did it backwards or forwards, I'm still going to get the right answer. So there's a typical AP problem. We shall see you tomorrow.